All right, so welcome everybody to the talk about open source distribution. My name's Stephen Shin. I run the developer relations team at JFrog. Have been at JFocus almost every year for a while. So you might have seen my previous talks on maybe like, one year I had like a line follower robot we played around with. I can't remember what I spoke about last time, but anyway, I've given a lot of different talks here, and I think this one is interesting. So we're going to talk about a new open source project that we bootstrapped at JFrog. It's entirely open source and community driven. We just finished donating it to the CD Foundation, so it's now part of a vendor neutral foundation. And this should be an interactive session. So I'm going to keep talking if nobody stops me. But anytime you want to raise a question, or you have an idea, or you just want to stretch because it's too much sitting, just move about and shout whatever you want, and it's all good. Okay, so what I'm going to start with is I'm going to give some examples of why we need a system like Pyrsia. And I think that really what's happened in our industry is we're all heavily reliant on open source software. So if you're building commercial systems, your code base, if you include all the dependencies, is probably at least 85% open source code. And when we rely on open source code, we also have reliance on how secure and how well built and distributed the libraries are. And there have been a lot of attacks on the software supply chain over the past couple of years. Now, a bunch of these have made headlines, and so I think if you're a software developer and now your parents or loved ones finally know what you do, because of this, that's unfortunate. So hopefully they actually care about what we're doing for software development, not just the fact that there's all these fancy headlines. But the big one which kicked off all this concern was the SolarWinds incident. And this was an attack on the CI/CD system in particular. They were running, it doesn't matter what the CI/CD system was in particular, but they were running TeamCity internally. The attackers got into their corporate network and were able to hijack the builds, which were building and distributing their software. So they modified and put exploits right before the code signing. And then SolarWinds was supplying their software to government agencies, a whole bunch of other companies with a signed certificate from them. And so when the target companies received this update, the clever hackers had put in backdoors and malware so that they could then get into and infiltrate all of those organizations. So the fact that this was such a large exploit affecting a lot of government agencies and companies prompted the US government to release official guidance from the Biden administration on how to counteract this. NIST and other government departments have also started guidance on software bill of materials and what companies need to do. But I mean, we continue to get additional incidents like the Log4j incidents, which happened about a year ago. Who had to patch a production system or upgrade? Okay, everyone in the room, pretty much. So this was pretty widespread as well. And again, like if you look at this incident in particular, it was an attack where an attacker could use a JNDI reference inside of it to pull back and execute arbitrary code. It wouldn't affect you if you were just using the Log4j core, but then if you were using the full Log4j, then you were vulnerable to this exploit, and everybody had to start updating systems and responding to attacks like this. And so these all happened, a couple years ago or a year ago, but we still keep seeing attacks. So anybody hear about this one just a month ago? Okay, good. So CircleCI finally announced the cause of the problem. If you were using CircleCI to build your software, all you got was, hey, your secrets could be exposed, rotate your keys, and make sure you don't have any dependent systems which are vulnerable. So they, on their final report where they talked about what actually happened, so it was around December 16th of last year, where one of their employee laptops got compromised by malware, which their antivirus software didn't detect. They were able to pull credentials to get an authenticated session off of that employee laptop. And then they were able to chain that to get access to a bunch of internal databases and different systems where they exfiltrated data. The data that they actually were able to use was some of the systems they actually, they encrypt everything at rest, so they couldn't get data off encrypted systems, but there were some running systems where they got dumps of memory and they got the unencrypted secrets, and then they used those secrets to then get into other systems to attack those systems. And the way Circle CI found out about this incident was other companies reporting their systems were compromised by the stolen Circle CI. Well, the secrets which were contained in Circle CI, which were exfiltrated. Okay, so that like this whole set of things, you know, it raises a question like, where is our stuff being built? Actually, a lot of open source software distributed by Linux Foundation, the CNCF, is built in Circle CI clusters and machines. How is it being validated for the authenticity of where it's coming from? And these are just like a few isolated incidents in a much larger threat to our entire ecosystem. So we're talking about few security incidents at the tip of the iceberg, but there's a whole wider set of vulnerabilities in the software supply chain that leave us potentially vulnerable in our corporate projects. Okay, so some incidents which didn't get as much media, but I think are also interesting, affect the central repositories which we all use. Who uses or trusts one of these systems? Okay, almost everyone in the room. Everyone who didn't raise their hand, they might use it, but they don't trust it, probably. So, I mean, we're all building software. Obviously, you're grabbing from Maven Central, PiPi, Ruby Gems, etc. And I think Dan Laurent has a great quote about this. He's the author of SigStore and now works at ChainGuard. So every time you pip install GoGet or Maven Fetch, you're doing the equivalent of plugging a thumb drive you found on the pavement into your computer. So we're all taught like this is really bad. Don't pass around thumb drives. Actually, thumb drives are still a way that hackers get exploits onto personal machines, if you can believe that. But we're all developers. We're pulling software off of these systems, and how safe are these systems when you actually get to it? So one of the exploits against these systems was the dependency confusion attack that Alex Bersan popularized. It was known to be a potential issue for a while. And basically what he did is he took an exploit, he packaged it up and actually figured out how it could be executed in practice. And then he submitted a bug bounty against a whole bunch of companies for this exploit. So part of what he did is he figured out a way to exfiltrate the data. So, you know, if you attack a vulnerable system, you need to figure out how to now get interesting data out of it. So he was using a custom DNS server and then exfiltrating the data by sending what looked like, you know, DNS data going across the wire, so you get past the firewalls and the other systems which are looking for data. The way the exploit worked is that he would find packages which companies used internally by their namespaces. So one of the features of NPM is when you go and you request something from NPM, the information you're requesting on which packages and which libraries you're looking for are actually open. Like they're not encrypted, everyone can see the traffic. So you can actually man in the middle and get information on what libraries people are requesting. Typically, people don't differentiate between like what's corporate libraries and what's open source libraries you're requesting. So NPM gets lots of random requests on corporate libraries as well as open source libraries. Of course, it can't service something if it doesn't exist. But what he would do is he would figure out what packages companies like Google, Apple, others were using internally. He would put a newer version of those libraries into NPM, because you can just publish whatever you want. And then if you were using for example, a vulnerable package manager, which maybe had a repository which combines internal and external things into a single source, it would go and it would request stuff against the internal library and against the external one. It would see the external one's newer and say, ah, here's the latest version. You now have version 666 of awesome corporate lib. Now, of course, this is horrible. Now you have a vulnerable library which you're pulling down off of npm, and bad things happen when you let little cats push red buttons or keyboards. My cats love jumping on my keyboard at home and typing Slack messages to my colleagues. And there are ways to solve this now. So most of the package managers which people use inside of corporate networks like Artifactory now specifically by default will not go to npm or external repositories to resolve things which also exist in internal repositories. So that protects you by default. And you can also make sure that you're resolving dependencies against the right location to avoid pulling things from external sources. But Alex was very good at profiting on this. So he submitted to dozens of bug bounties simultaneously in an orchestrated effort. Collected on all of them simultaneously and made 130,000 USD on this exploit. So no one was harmed in the exploit. It was all just test purposes to prove the exploit existed. And the world's a safer place now that we know not to do this. PiPi is, again, if we're using Python packages, is another package manager and central repository which pretty much lets you do whatever you want in terms of adding new Python modules to it. So our security research team looked at PiPi. They did a full investigation of all the different packages in PiPi. They looked for malicious code and packages which were potentially vulnerable or might have zero-day vulnerabilities in them. One of the security researchers is Vedder, and he's one of our researchers in Israel. He uploaded a wonderful new package, Vedder 0.8. Anyone want to guess what his package does? What? Install bad stuff. So he could be installing bad stuff, but he just takes you to his website. But it's an entirely useless Python package. There's no reason he should be submitting random stuff, or any of us should be submitting random things to PiPi, but there's no validation, there's no checks on anything. You can upload whatever you want. And we actually found a lot of malicious packages in PiPi. So what they did is they specifically looked for packages which were doing things like accessing certain directories where you shouldn't access it, using obfuscated code. So trying to hide what the package was doing. And then they used forensics techniques to figure out what those malicious packages were doing. They got about 300,000 hits. Or they searched 300,000 packages and they got initially around 6,000 hits. They started looking through them to see what these different packages did, and they found a couple interesting ones. So one of them was Noblesse optimizes your PC for Python. And what Noblesse actually does is it exfiltrates your credit cards and passwords through Discord. And another one was Pythagora, and this one, runs Python code received as a string from a network C2 server. So it gives you arbitrary code execution on device. And the other thing about this, and also npm, Maven Central doesn't have this problem, is on installation of the package, like when you download it, there's a executable package installation where they can put code. So you don't even have to execute the library to be affected. You just have to have a dependency which pulls it down from PiPi, and then you're immediately affected by it. So in this case, what they were doing is they were taking advantage of the fact that all of us who use browsers and put passwords in our browser, you're storing your passwords, and the browsers will make this very secure against websites attacking your password database. But if you have an application installed on your computer, it's just a SQLite database that's in plain text. So they can basically pull your passwords directly off your disk once they have like user admin privileges to the right directory in your user folder. So what they would do is go and pull this information from the SQLite database, decrypt it using crypt unprotect data, pull back passwords and other information, and the actual source code for doing this is very simple, right? So this is the decrypted version of the the code, which did the password exfiltration. Okay, so that's the second example, and I have one more example before we get to talk about Persia, and this is another exploit which our security team found. So this is a very common security exploit which a lot of different organizations try to use, and it's basically typo-squatting. So you'll see a lot of packages submitted to, in particular, NPM, but also other package repositories where they try to come up with something which is like a common typo or spelling mistake, or in this case, leaving off the namespace for Azure. And if people accidentally make a mistake in their code, then you end up pulling down the wrong package and you end up with malicious code. So in this case, we found Azure core tracing and a whole bunch of libraries which were, if you left off the Azure prefix, you ended up with this instead. So this is core tracing without the prefix. Of course, this is a malicious library which was uploaded, and they also were careful enough to make sure that, because they did this for hundreds of different packages, so they created a special bot which would create different users so that each one was uploaded by a different person, so it wasn't easy to trace all of the vulnerable packages. This way they could load up NPM with a whole bunch of packages and make it harder to identify. So we found 218 packages at Azure Tests, at Azure Tools, at Catalang. These were designed to exfiltrate data from developer machines, kind of like the other Python exploit that we talked about. In this case, we caught it before it was actually widely known, and then NPM pulled down all of the affected packages. So they got rid of this before it was actually used as an exploit. But there's a lot of examples of typo-squatting and this type of thing happening in public repositories. Okay, so we talked about a bunch of different exploits. So how many folks use and trust their central repositories? Okay, fewer hands. Okay, so this is a problem in general that I think we need to solve. There's some information here about our security research team if you're interested about more of the research and the exploits that they do. Basically, we acquired a company in Israel called Vdoo, and they've been with us at JFrog for about a year, but it's some of the best military trained security researchers. So they try to find different exploits or attacks or what the hackers are trying to do. And then we add it to our vulnerability database, and we also publish the results on this website, research.jfrog.com, where we post different security exploits. Recently, we just found a big security exploit in Rust for the one of the web libraries, and it was very easy to do denial of service attacks against pretty much any website written using Rust technology if it used this underlying web library, which has since been patched now. Okay, so let's talk a bit about the Persia project. Okay, this is also my first time presenting on a Steam Deck. So I'm giving this a try as my regular travel computer, because carrying around a laptop and pulling it out and trying to do stuff is awkward. So far so good, right? Okay, so Persia is, as I mentioned, it's an open source project, and the goal is to enable open source developers and folks who are building open source software to have a secure distribution. And myself as an open source developer, having written a lot of different libraries and IDEs and projects over the year, I mean, at the end of the day, what you want to do is you want to get your software to the user, whether it's a developer or somebody else who's going to use your software in an easy, secure way, which also doesn't cost you any money because you're probably a starving developer. And I think that Persia is a good solution to this problem, and it tries to modernize and use kind of some of the latest technologies to solve the problem of secure distribution of software. Where the term Persia comes from is it's a Greek reference to a system which was used to communicate over mountaintops using torches. So basically, times of war or communicating information like shipping or emergencies, what they would do is they would put 10 torches up, 2 sets of 5 torches, light the right torches to pick the positions in the grid, and they would send letters one at a time across long distances using the system of torches. So I think it's a cool analogy of communicating information, distributing information in very early society, and it kind of shows us how people are creative at finding different ways that they can solve problems like this and find innovative ways to do things. If you look at the overall supply chain, software supply chain, there's a bunch of different points at which an attacker can get in. And we've talked about some of these with examples of security exploits, but this is the software supply chain levels for software artifacts, or SALSA, which is an OpenSSF project. And what they do is they map out what all the different possible points where you could have a vulnerability in your supply chain. And it starts with your code base, so your source code, whether it's been reviewed, if you have a vulnerable source control system. Then you move into the build system, like SolarWinds is an example of a CI/CD, vulnerable CI/CD system. Circle CI being exploited is a massive vulnerable CI/CD system. Then you get into packages, so whether your packages have been compromised, if you're using a bad dependency, if you bypass CI/CD. And the goal of Persia is not to solve all of this, but most of it. So if you start with bad source code, right, if there's a defect in the source code, if there's a 0-day vulnerability that's later discovered in the source code due to coding error, or if there's like a memory safety issue or something that can be exploited, we can flag those as known vulnerable libraries, but our goal is not to become a security auditor unless somebody tells us that we should be reporting it. But the goal is that once the source code, once you have the source code which you want to build and use, everything from that point, from building it to distributing it to having a good provenance and software build materials to trace it, should be taken care of and should be done in a secure way. So basically everything C through H is what we care about. If you start with vulnerable source code, that's kind of, we can't help with that. Okay, and then the kind of the 3 tenets of Persia are: we want to build a open source distribution which is reliable. So for the most part, we don't really worry about this anymore. But if you remember the good old days before Microsoft acquired NPM, there were some quite severe and long outages in NPM. And it still goes down if you look at the tracking information for a couple hours about once a month. So every time a upstream central repository goes down, it interrupts the developer workflow, potentially interrupts CI/CD systems if they haven't cached the artifacts. And it's a general interruption of work. So we want it to be as reliable as possible so that you can always access the artifacts which you need for your builds. Secure, I think this is probably the biggest selling point for Persia, is having a modern, secure architecture for validating the libraries you're getting and ensuring that the basic guarantee of Persia is whatever you download off the network, it will be the same artifact as if you built it yourself. So the guarantee is we don't guarantee that the source code, the open source source code, is defect free or vulnerability free. But we do guarantee that you'll get the same results if you built that source code. There's no intermediate actors. There's no injection of malware. There's nothing like what happened to, for example, SolarWinds. And the last one is open. So a lot of the distribution systems where we get open source software are not fully open themselves, right? So if you want to inspect the running source code of what's running on the central repository to deliver artifacts, if you want to see the architecture of it, if you want to understand exactly how it's all how it's all built and what it's running. That's not always an open architecture, and it doesn't give you a way to validate what's happening in the distribution of software artifacts. So we're also want to keep this as an open source effort, entirely transparent and open about what's happening behind the scenes. And when you look at the design of the network, the first thing we do for reliability is we create a peer-to-peer distribution network, so that now you're not getting your artifacts from a single central server or from a content delivery network. You're getting it from other peers in the network. And there's a couple advantages to doing this. Now, one advantage is reliability, because now you're not reliant upon a central source for getting artifacts. If you're getting something which is popular, so a common open source library is something a lot of people are using, then you can get it from almost any node on the network and multiple nodes a la BitTorrent. So that gives you better speeds and also better reliability of retrieving networks. The other advantage of this is one of the problems with pulling things down from a central repository, and in particular a central repository fronted by a CDN, is you have a lot of network hops bouncing in and out of different cloud providers depending upon how you're getting software. Historically, before everything got centralized to basically 3 cloud providers, having a CDN and then distributing off the CDN to like companies and individuals and stuff made a lot of sense. We actually run a JCenter now, which proxies Maven Central, and I end up paying the bill for it in the DevRel team. And when we do the traffic analysis, our own servers are causing a lot of traffic bandwidth because it bounces from, we have a cached version in GCP, and then we have it fronted by a CDN, and then it goes back into GCP or Amazon or other servers. And the traffic in and out of the clouds, every time you get network ingress or egress, you're paying for that bandwidth in and out. This also solves that problem because you're using a peer-to-peer network where you're pulling from nodes, which give you the shortest latency and hops. So traffic is basically staying inside of the same corporate network or inside of the same cloud server network most of the time when you're downloading artifacts. So that's another advantage of a peer-to-peer topology like this. And also it's sustainable without having a lot of corporate investment. I think open source, while it requires some investment from companies and folks, you make sure that if that investment goes away, or if you don't have that investment in the future, that it doesn't impact the quality of service or the ability to deliver artifacts. Okay, so that's the first thing, is building a peer-to-peer network. The second part of the architecture is how we do builds and build verification. So rather than having a single central server building software and then distributing it, where you're relying upon the company which is building it, we're building it across multiple different nodes and then comparing those nodes to make sure that you get the same artifact, and then distributing an artifact which has been verified by multiple different nodes. And I'll talk about how this works in more detail in a little bit, but basically what this means is that let's say one of these nodes was running and got compromised by a threat actor, then it would fail validation because it wouldn't match what the other nodes are getting as a result, and that you wouldn't have that malicious artifact distributed on the network. Today, we're basically relying upon artifacts which are either built on the central repository server. For example, Docker Hub does a lot of their own builds now for their certified builds. Or you're relying upon the projects to build it themselves. So they might be using GitHub Actions or Circle CI or some other server. And you don't have a lot of guarantees on the system which was building it, and also on the authenticity of different folks who are involved in kicking off the build or setting up the build. So this gives you a lot more control and security around what's actually being distributed on the network, because you know that it's built off this source, it's built by multiple different parties, and then it's verified against different parties. Okay. And the third part of the architecture is the immutable transparency ledger. So this is the way which now you downloaded an artifact off the peer-to-peer network. How do I know that this is a valid artifact? How do I know it was verified by different parties? So all of this gets recorded in a ledger which can't be changed once a record's been written to it. There's a consensus algorithm where different blocks get added to this chain so that guarantees that once it's been agreed upon that this is the correct set of data and verifications, then it can't be changed in the future. And this allows you to go back and verify that everything you're pulling down off the network is exactly the artifact you want. It's validated to be against this source version which gets built. And these different nodes have built it and verified that they got the same result. So it gives you a way of tracing back and knowing exactly what you're downloading and the provenance of those artifacts which you downloaded. Okay, so I'm going to go into more detail and more architecture slides and stuff. But before I do that, any questions? Because I've thrown a lot of stuff out. And let's start with you. And I'm going to repeat the question. Or you want to do mic it?
No, you repeat it. I think it's easier.
Okay, I'll repeat the question for the video stream. Go ahead.
How do you handle vulnerable version of a library, for example, Log4j, old legacy versions?
Okay, so the question is how do we handle vulnerable versions of libraries? And actually, this is kind of a larger question of curation of libraries. There's some dependent issues like how do you know like a new version is related to the same project if for example, it changes code bases or version control systems. And there's a whole bunch of curation as well required for this. So, so this hasn't been implemented yet. Currently, we're just pulling off of a GitHub repository which doesn't have the full workflow that we want. But basically, the idea is that we'll have a public GitHub repository with all of the recipes for building from source to binary release and information on how to do that. It'll be curated by the community, so they will decide, you know, through a review process how to update it, making sure it's the latest information. And it's also all public, so you can see exactly what's going on with different people reviewing and updating the records. And that's what's then used to go through and do the builds for the Persia build system. And similarly, if we have reports of vulnerable libraries, we can mark those as vulnerable in the system so that you know that this library has a vulnerability. Or if it's, for example, published in the NVBD, the National Vulnerability Database, or other public sources for vulnerabilities, we can also show that to users. Now that said, the vulnerable libraries are still distributed over Persia. So it's an immutable network. Nothing gets deleted or erased or removed from history. But as a user, then you have the information that there's potentially a vulnerability in this which may or may not affect you. And you can choose not to use that library based upon that information. Something else about vulnerability databases, I don't know if folks here deal a lot with like incident reports and vulnerability databases, but basically something like 80 to 90% of vulnerabilities that are reported by vulnerability scanners are not applicable for your application or your use case. So while the library may have a potentially vulnerable bug in it, if you're not calling the API or you're not using it in that way, or if you don't trigger the vulnerability, it may be fine for your application to go ahead and use the vulnerable library because it doesn't actually affect you. So the decision of whether to use a vulnerable library really has to be up to the application developer rather than a tool saying, oh no, this is vulnerable, we're not going to distribute it. Okay, that's a good question, and yeah. Okay, so the question is, would it be possible for like bad actors or government agencies like the CIA to specifically set up nodes to take over the network and cause problems? So a couple of things about that. So just implementation-wise, the peer-to-peer distribution networks based on libp2p, which is the same underlying peer-to-peer infrastructure as IPFS. We're not using the full IPFS stack. We're just using their libp2p library for the distribution. And you can distribute whatever you want over the peer-to-peer network. Even potentially, you could set up a node and distribute malicious things, but those wouldn't validate against the blockchain. So to actually get a malicious library in the Persia network and have it validate, you would have to break consensus. You would have to get a new block added to the immutable ledger, which has invalid information that says that this vulnerable item which you've uploaded is valid. And the way in which we prevent bad actors from breaking consensus is we're not trying to do. What we're doing instead is there's a set of authority nodes which they participate in consensus, and they're run by member companies who are part of the Persia project. So you have about, currently half dozen, but in the future maybe 10 or 20 authority nodes which participate in consensus, and they guarantee that the right transactions are getting validated. If an attacker wanted to hack the network and attack the authority nodes, what they'd have to do is they have to compromise 2/3 of those companies' nodes to then put a bad record on the network. Now, that's possible, but that's a lot harder than, for example, hacking Microsoft and accessing GitHub and just taking over the world. So you'd probably start there. Yeah, good question. Any other questions? Okay, so I'm gonna go through some more of the detailed architecture. How are we doing on time? I think we're good till 12, right? So I'm standing between all of you and lunch. And I think this will also help to describe a little bit. This is a little bit about the CD Foundation, which is part of, and then other companies which are part of the Persia effort, including Oracle, Huawei, FutureWay, Docker, Deploy Hub, JFrog, and we're open to other companies contributing and being part of the effort. You don't have to be a CD Foundation member company to contribute to the effort. So we have some individuals who are just helping hack on the source code. We have companies which aren't part of the CD Foundation which can also contribute. We have one of the contributors from IBM as well, and IBM is not officially a part of either the CD Foundation or the Persia project. So you can openly contribute to it. This is like a super high level architecture diagram of kind of like the way of thinking about the Persia system. So all of the nodes, and just as a developer downloading software, you're running a little tiny node on your laptop. You're pulling libraries off the network, and then you're just distributing libraries you download. So like you're not distributing the world, you're not sucking down all of the open source code in the world. But if you pull down the latest version of Log4j and someone else requests it, then they may get it from you in the peer-to-peer network instead of from the authority nodes. So we have storage and retrieval. We do source to binary builds, but not on the regular nodes. Those only happen on the authority nodes. So again, like we're not using the developer resources to build the libraries. That all happens on the set of nodes participating in consensus. We have planned integrations, current integrations with Docker and Maven, so you can use Docker images, use and distribute Docker images, and also Java jars on the network. We have planned integrations with Go, NPM, Conan, which is a C and C++ package manager, Cargo, which is the Rust package manager, etc. We have a command line interface for Persia, integration with, basically for Java, it sets up a local proxy, and then that way you can point your Maven or Gradle build to the local proxy, and then the local proxy sucks artifacts off the Persia network. If it can't find it on Persia, it falls back to Maven Central. So you can choose like if you want to fall back or not for security issues. And we have a new plugin that one of the team members just created for visual code. So if you use Visual Studio Code, we have a cute little plugin which will like show you where you got the library, if it was from Maven Central or Persia, lets you start and stop your node, and gives kind of a better developer experience for the project. To understand how the authorized nodes work in the network, so like this is an example showing the like 3 authorized nodes. Each one's running a Persia node for distributing and participating in consensus, so that's the little dot. And it's running a build pipeline server alongside it to build open source libraries which get requested from the network. Nothing gets uploaded to the Persia network, so it's not like I'm an open source developer, I'm going to submit a jar or a Docker image or something. What you do is you say, I want this library, and if it matches in the curated list from the earlier curation I talked about from GitHub, then it will build it on one of these nodes, or on multiple nodes. It'll verify it across the nodes, and then it'll distribute it on the Persia network. And the rest of the network is all of the little blue nodes. So that's all the other nodes, which it might be your CI/CD server running Persia in the background. It might be your like laptop or you're developing where you just set up a local Persia instance. It's designed to be super lightweight and relatively transparent and not resource heavy, so you can just have it running alongside your normal development environment and use it. So that gives you an idea like what the overall network topology and structure looks like. And this is a more detailed diagram of the Persia architecture. And there's a bunch of different services which we're running on the node. So that's the left side there. So as I mentioned, we have a CLI interface for interacting with Persia directly. For Java and Docker, we also wrap things so that the Docker commands can pull from Persia directly. Same thing with Maven and Gradle. We put a little proxy in there so those can access it. Locally, we have an artifact service and local artifact storage for all of the artifacts which you pulled down from the Persia network. And then we also have all of the blocks from the network. So you get the transparency ledger downloaded locally for verification. Then you can verify by the signatures all of the different transactions on this, which happened with the authorized nodes. We're running libp2p for the peer-to-peer network. Only the authorized nodes participate in consensus, and the algorithm we're using for that is Aleph BFT, which is a recent, fairly modern blockchain implementation. And it has a few advantages, which I think are very good for this type of network. So one is it has the usual guarantee that you have to compromise 2/3 of the nodes to have an invalid transaction. But the other one is it's also very resilient to denial of service attacks. So before you take over 1/3 of the nodes, there's no reduction in throughput of new blocks being added to the blockchain. So if our bad actors, who you mentioned earlier, like the CIA, let's say they can't insert bad transactions, but they just want to do a DOS on the Persia network, they still have to compromise 1/3 of the nodes, and then they can start slowing down the network. And then they can't actually do anything malicious until they get to 2/3 of the nodes. So it's going to be a while before they hack our network, hopefully, if they haven't already, because they're very good at this game. And then the right-hand side there is the build pipelines for building Docker and Java images. So we build those on standard CI infrastructure with container images and isolated machines so that you're not exposed to another potential exploit on the network would be if you could submit packages to build which had malicious code in them, which would allow you to take over nodes, and then that would allow you to take over all the nodes at once. So we isolate those from the Persia nodes so they're not running on the same infrastructure, so the builds can't directly compromise the Persia node. And also run in a container, we can easily throw it away so that there's no side effects from one build to the next running. Okay, so it's a little bit about the Persia service architecture. Oh, and then the next thing I have is how to get involved. Okay, so where can I find Persia? So Persia.io is the website. We have a distribution there you can try out and start using today. So give it a try, give us feedback, and you know it's work in process. I think we're up to 0.3 or 4. So we don't consider it production ready or a GA release yet, but we're working towards that. Also join our Slack community. So on the CD Foundation website, CD Foundation/community, you can join the continuous delivery Slack, and all of the Persia work happens in there. So there's a Persia channel, Persia alerts, Persia notifications, etc. So you can join those channels and ask questions, find out how to get involved. We also have weekly community meetings as well. So that's also posted on the Persia website. So you can join those calls and chat with members of the Persia project about what's going on. And all the Persia code is stored in GitHub. So you can check out the project on GitHub, see the source code, and get involved in the project, submit issues, submit pull requests, and be an active member of the community. We encourage folks to help out. Okay, and questions and answers. So I think I'm about on time. So while we're doing questions and answers, I figured something fun to do. This is entirely optional. So after this, I'm going to go back to the JFrog booth, and we've been running a raffle for a switch. But I figured I'd bring the raffle code with me. So in case you haven't signed up for the raffle, then you can do that now while we're doing Q&A. And then potentially you get a nice switch. I think it's an OLED switch, so it's the nicer, newer model, which Cassandra doesn't have yet. You have the older one, right?
Yeah.
Yeah. Okay, Cassandra's my daughter, and she was also doing kids workshops here and KubeCon and other conferences. So she's becoming a conference bum. Okay, so any additional questions or thoughts? Yeah.
Maybe I misunderstood something here, but if my developer machine has served binaries to other developers across the world, isn't that leaking information on what binaries I have on my machine? And isn't that like an excellent way of finding other developers who are using vulnerable binaries?
Okay, so that's a good question. So the question was if I'm using Persia, and if Persia is advertising like what libraries I'm using and things I'm downloading, then isn't that a potential information leak? So that's correct that folks can find out what open source libraries you depend upon if you're part of the Persia network. I think if you are part of a company, right? Like let's say you're inside of a corporate network, you might choose to put a gateway between the internal users of Persia on your VPN and then the external Persia network to block exfiltration of information about what open source libraries you're using. So that might be a good way of avoiding that from a corporate level. But it's true that you like the way libp2p works is anything which you're redistributing. You do advertise blocks that are part of that, so people can figure out by block advertisement and IPs what libraries that you've downloaded recently. So it is leaking a little bit of information that way. And you can always turn off redistributing artifacts if you're really worried about that. So you can be a leecher and just pull things and never never redistribute, which is another way of, like, if you really want to stop the information backflow. Okay, so that's a good question. Yes.
Can I use this, for example, with Azure DevOps, assuming I'm in a very locked down environment?
Sorry, how would you?
Can I use this from Azure DevOps?
Oh, from Azure DevOps in a lockdown environment. So if you wanted to use like pulling things from Persia from Azure DevOps. So I assume you're probably using their CI/CD for doing your builds, right? Okay. So theoretically, I haven't tried it. You should be able to run commands to like set up Persia at the beginning of your script and then like pull things down from your usual build in Azure DevOps from the local Persia node. So theoretically, it should be possible, but we haven't tested it. So you might run into issues with, for example, it might have trouble setting up the proxy with the ports or other stuff when it tries to launch Persia. So it's possible it would work, but it's also equally possible you'd hit some bugs.
Yeah, the main issue I'm concerned about is that I want to pull public artifacts from Persia, so everything that you can find on Maven Central, and all the internal artifacts I want to fetch from Azure feeds, because that's where they are. That is the main.
Yeah. So Persia really only provides open source libraries. So you could use this for pulling open source libraries. Yeah, and the other like binary packages, you should pull them down from your package registry. Yeah, but it may be possible, but we haven't tested it. Okay, good question. So I want to thank everybody for joining the Persia talk. Welcome you to join the project. Hopefully you're interested to contribute to the project. And thanks very much for coming to the talk here at JFocus.